Today we will discuss electrical potential with the help of the analogy. Okay. Now observe here, with the help of the motor I am pumping the water into the overhead tank. This is overhead tank. Observe closely. Certain amount of work has been done to bring this water into overhead tank, and due to this work certain amount of energy has been spent on this work. So some energy is spent. What is that energy in terms of mechanical energy, or in terms of electrical energy, or in terms of motor energy? Whichever the energy we have spent on the motor, that will be stored in the overhead tank in the form of this overhead tank. We stored water, but from ground level, say somewhere it is ground level here. Okay. So from ground level to tank, overhead tank, we will have some height. As per the classical physics, the amount of energy stored in the tank is mgh, that is potential energy. Okay, that is potential energy. So the energy stored in the overhead tank. Now if I connect this overhead tank to the a small turbine which will rotate with the help of the water on the wheel of the turbine. Okay, and to rotate this turbine, some amount of work is done here. Work done by water is responsible for the rotation of the turbine. So amount of work done, whenever the water is over in this particular tank, then work will be zero. So water tank has, or else overhead tank has capacity to do a work. What is that work? To rotate this turbine. That means due to the amount of energy stored in the overhead tank, it has a capacity to do work. But how long it will do? It will do as long as it has some water in that. Whenever water is over in that particular tank, it has no use. That means work done due to, say suppose it has 1000 liters capacity. So work will be done until this 1000 liters of the water is completed. So the work done per mass of that, per unit mass of the water, is the capacity of the water tank. So how much capacity does water tank have? That is the question here. What is the thing? How much of the capacity? The capacity of the water is, capacity is what? Capacity is to do work, right? Capacity to do work. What is the work? That is to rotate the turbine. The turbine is rotated as long as the water present in that water tank, and the turbine will rotate it long if you have more water. That means the amount of the work required for this turbine is depend on the water present in the overhead tank, or capacity of the tank. And if you want to speak closely regarding the capacity of water tank, capacity is directly depend upon work done by tank. Work done by tank per mass of the water, or per water. amount of the water simply. So the capacity to do a work is what the potential energy stored in that potential of that water tank. So now I can say that the potential of water tank or potential energy of water tank is directly depend upon what? Directly depend upon the capacity to do a work, capacity to do a work per amount of water, right? So we will use the same analogy for electrical domain. Observe clearly, if I have a body, this is electrical body, electrical body, okay, and to this body or electrical material simply, to this body I have applied some amount of energy or some work on this body to get some free charge in that, to get some charge in that. So it has some potential energy. So what is that potential I need? What is that potential? Potential is capacity to do work per unit charge. So what is potential? Potential is work done per unit charge, and this can be expressed in joules per coulomb or volts, okay, and simply if W equal to 1 and Q equal to 1 coulomb, this is 1 joule, this is 1 coulomb, then what is the potential now? The potential will be 1 by 1 volt, that is called 1 volt, okay, that is unit volt. So what do you say? Every electrical body will have some potential. That potential is represented by VA, and I have some other body, something like this B, so it will have some VB, right? And it has some capacity, and it is also have some capacity. So the difference in these two capacitance is the potential difference between these capacitances, that is potential difference between those two bodies, that can be represented as VAB, right? For suppose if I have in A, if I have the potential, say suppose it is A plus 12 volts, and in another body say it is B, I have the potential of that body is A plus 8 volts. Then what is the potential difference between these two bodies? VAB equal to VA minus VB, that equal to 12 minus 8, that equal to 4 volts. In this way we will calculate potential difference. But observe clearly, if you connect these two bodies with any conducting material, the electrons will flow or the charge will flow from higher potential to lower potential. So current will flow from current will flow from where to where? From A to B. So in this way we will identify the direction of the current. Direction of the current from higher potential to lower potential always. This is a standard notation. Always from higher potential to higher V to lower V. Okay.